Great to see you here again. Welcome to the YouTube channel of the Ceuster Academy. If you're here for the first time, do not forget to click the subscribe button, click the bell so that you get a notification every time we post a new video. This series or this video is about divisibility. It's part of what we call discrete mathematics, and we're going to talk about natural numbers, integers, and their properties related to division. We started with natural numbers. You remember those natural numbers were obtained by counting. Originally, the natural numbers started from 1 and later 0 was added. So there are two possibilities. We say the natural number starts from 1 or starts from 0. Basically, we can say they start from 0 now, but originally it was different. When we looked at the integers, we added the negative numbers. So for 1 we added -1, for 2 -2, and so on. This is the set of the integers, and typically what we're also going to talk about are the positive integers, z plus, which are also the integers from 0, 1, and so on. Now when we look at the integers a, b, q, and r, they are in fact the numbers that I want to define the integer division with. Now we know when we divide integers that not all integers can be divided or by another integer giving an integer. For example, 2 divided by 1 is 2, 4 divided by 2 is 2, but 5 cannot be divided by an integer and giving an integer. So what we do is we say the integer a is equal to a q quotient multiplied by the divisor b plus a remainder. For example, the number 5 divided by 2, we can write it as 2 times 2 plus 1. So q is the quotient. In the case of 5 divided by 2, this is equal to 2, and r is the remainder. So these are the basic elements that we're going to use to define what we call modular arithmetic. But let's now have a look at some examples. Let's say we have a equal to, for example, 15, b is equal to 4, and then we can write a, let's say a is q times b plus r, and when we replace a in here, we can say 15 is equal to q times b, b is 4, so we can say it's 3 times 4 plus we have 12 with a remainder of 3. So basically we can say here that q is equal to 3 and also the remainder is equal to 3. So both of these elements are in fact giving us those important factors about the division. What we also can define now is in fact the divisor, and we can say 15 divisor 4, is in fact 3. So when we have this, basically we say that a divisor b is in fact the quotient. Another element we can say 15 modulus 4 is 3, and here we find the remainder of the division. So basically I can say a module b is r. So basically these are formulas that we will use in modular arithmetic, and these are the basis of modular arithmetic. Let's have a look at some other exercises. Another example is 39 and 13. So what do we have here? I can say 39 is 3 times 13 plus 0. In this case, 39 can be divided by 13, and 39 is a multiple of 13. We can then say that 39 division 13 is 3, and the modulo of 39 divided by 13 is 0. So this was another exercise. We can have another one so you get the heck of it, that you understand, before we continue with the modular arithmetic. We look at 45 and 4. So what we can say is that 45 can be written as 11 times 4, so we have 44, plus the remainder is 1. And we can say that the quotient here is 11 and the remainder is 1. Or we can say that 45 divisor 4 is 11 and 45 modulus 4 is in fact 1. So these are some simple exercises, but let's have a look what we can learn more about this, and the things we will be looking into the next exercises and examples will be very important for the following videos. Based on what I said before, I could write A equal to Q times B plus R, and Q is an integer, R is also an integer, and R is smaller than B. Now when I look at this, I can start with Q equal to 1. So when Q is equal to 1, I call this A1. And I can say this is 1 times B plus R. Now when Q is equal to 0, I can say that A0 is 0 times B plus R. Now what's important here, we already know that A1 modulus B is R, and the same is valid here. A0 modulus B is also equal to R. And we can go for Q equal 2. We find A2 is 2 times B plus R, and we also know that A2 modulus modulus B is equal to R. What we can say here is that AI, whatever value of I, which corresponds with I times B plus R, and I is an element. So basically we can say for all those values, I can say that AI modulus B is always equal to R. And that's a very interesting property that we will be using later in modular arithmetic. So that was it for this first video on divisibility of integers, and we will see more about modular arithmetic in the following videos. I'm looking forward to seeing you there, but do not forget, subscribe if you didn't subscribe yet. Click on the bell button so you will not miss any of our interesting videos. But one thing before leaving, below in the text you find a link to our online courses and a very interesting discount coupon that you can apply, so you get a very nice price for our own online courses. Thank you and bye-bye.